Welcome back to the deep dive. Today, we are going to challenge a very specific mental image that most of you probably have. When I say scientific revolution or paradigm shift, where does your brain go?
Usually, it goes to a high-tech lab with clean rooms, or maybe the ivy-covered walls of Cambridge or Oxford. We tend to associate big ideas with big infrastructure.
Right, exactly. We think of Silicon Valley garages or the bustling coffee shops of Vienna in the 1920s, but the stack of sources we are looking at today points to a completely different coordinate. We are looking at a small, dusty town on the Chotanagpur Plateau in India, a place called Giridih.
Which, to the casual observer in the early 20th century, was known for exactly two things: coal mines and a sanatorium for people trying to recover their health. It is about as far from a high-tech hub as you can get.
And yet this deep dive is titled The Giridih Connection, because this sleepy town somehow became the nexus for three of the absolute titans of Indian science. We're talking about Sir Jagadish Chandra Bose, Sir Jnan Chandra Ghosh, and Prasanta Chandra Mohalanobis.
Yeah, these aren't minor figures. We are talking about the fathers of radio science, industrial chemistry, and modern statistics, respectively. They didn't just pass through Giridih, they lived there, they built labs there, and they fundamentally changed their fields from right there in the hills of Jharkhand.
So the mission for this deep dive is pretty straightforward. We need to figure out why there. Was it something in the water? Was it the geology? Or was it just a really happy coincidence that these geniuses ended up as neighbors?
The sources suggest it wasn't a coincidence at all. It is actually a fascinating convergence of three things: the unique geology of the region, the specific healing climate of the town, and the social network, a galaxy of peers, really, that turned this hill station into a powerhouse.
Let's start with that first factor, the climate, because that seems to be the hook that brought our first titan to town, Sir Jagadish Chandra Bose.
I asked J.C. Bose, the polymath, physicist, biologist, botanist, and arguably the figure who casts the longest shadow over the town.
Now, Bose wasn't a local. He was a Bengali from the city, so why did he end up in the hills?
You have to look at the context of the British Raj. Giridih was developed as a health resort. The air was dry, the altitude was moderate, and the water was thought to have digestive properties. It was a place to heal. Bose came for the quiet, but he stayed for the science. He actually bought a house there and named it Vigyan Kendra.
Which translates to Science Center.
Exactly. But don't picture a government building. This was his home. It became his sanctuary. And the work he did, both in Calcutta and refined in his thinking at Giridih, is mind-blowing.
I have to admit, reading the notes on his physics work, I felt a little cheated by my high school history books. We all learned that Marconi invented the radio. But the timeline here is, well, it's complicated, isn't it?
It is a classic case of scientific priority versus commercial patenting. In 1895, Bose made a public demonstration in Calcutta. He used microwaves, millimeter waves really, to ring a bell and explode a pinch of gunpowder from a distance through walls. This was significantly before Marconi's famous patent.
But it's not just that he did it first. The critique of Marconi and the praise for Bose seems to center on the actual mechanics of the device. The coherer. Can we unpack that? How does a coherer actually catch a radio wave?
Right. Let's get into the mechanics. A coherer is basically a switch that turns on when a radio wave hits it. The standard version at the time was a glass tube filled with metal filings. When a radio wave hit the filings, they would magnetize slightly and stick together, or cohere, allowing current to flow.
Okay, so it closes the circuit.
Yes. But the problem was, once they struck together, they stayed stuck. You had to physically tap the tube to shake them loose to receive the next signal. It was clumsy.
You can't exactly send Morse code quickly if you have to tap the device after every dot and dash.
Exactly. Bose completely reinvented this. He built a mercury coherer. He used a drop of mercury between two iron electrodes. The surface tension of the mercury and the oxide layer on the iron created a perfect, self-recovering detector.
So no tapping required.
No tapping. It was a solid-state diode detector, decades before semiconductors became a thing. It was incredibly sensitive.
And this leads to the Italian Navy coherer scandal mentioned in the sources.
It does. Marconi's famous transatlantic receiver used a design that was suspiciously similar to Bose's mercury coherer. The issue was that Bose refused to patent his work. He was an idealist. He believed knowledge belonged to humanity, not a corporation. So his designs were out there, open for anyone to see and copy.
That idealism seems to be a theme with him. But here is the pivot that I find really disorienting. He masters the physics of the inorganic, radio waves, metals, and then in Giridih, he basically abandons physics to study plants.
It feels like a hard left turn. But for Bose, it was a straight line. He was obsessed with the unity of nature. He had studied metal fatigue, the idea that metals get tired under stress and recover, just like muscles. So he asked, if metals act like life, do plants act like animals?
He wanted to prove plants have a nervous system.
Correct. But to do that, he needed to see them react. And plants move too slowly for the human eye.
So he built the crescograph.
The crescograph. This is another mechanical marvel. If you want to prove a plant flinches when you pinch it, you need to magnify that tiny movement.
How much magnification are we talking about here?
10,000 times.
Wow, how do you even achieve that without digital sensors?
Clockwork and levers. It used a system of delicate gears and a smoked glass plate. The plant's movement would nudge a lever, which nudged a gear, which moved a needle across a smoked glass plate, scratching a line that could be measured.
That is incredibly ingenious.
It allowed him to record the heartbeat of a plant. In his lab at Vijay Kendra, he showed that plants respond to light, heat, wounds, and even drugs and poisons. He demonstrated they generate electrical signals, action potentials, identical to animal nerves.
It is such a vivid image. This world-class physicist sitting in a quiet house in a hill station, poisoning a fern to see if it dies like a human.
And finding out that it does. He spent his final days there, bridging the gap between the living and the non-living. He died in Giridih in 1937, having proved that the physics of the radio wave and the biology of the leaf were part of one single truth.
So Bose represents the sanctuary aspect of Giridih, the quiet place to think. But our next titan brings us back down to earth, literally. Let's talk about Sir Jnan Ghosh.
J.C. Ghosh. Now, while Bose was a visitor, Ghosh was a son of the soil. This grounds our story in the industrial reality of the region.
Because Giridih isn't just nice air, it is mines.
It is. Ghosh was born in Giridih in 1894. His father was a mica mine owner and merchant, so he grew up surrounded by the extractive economy, coal, and mica.
He didn't go into the family business, though.
No, he had a different calling entirely. He topped the Chotanagpur Division exams from Giridih High School, went to Presidency College, and then to London. And that is where he shook up the world of physical chemistry with the theory of strong electrolytes.
Okay, I am going to need you to guide me through this one. Chemistry wasn't my major. What was the problem he was trying to solve?
So think about salt water. When you dissolve salt, an electrolyte, in water, it breaks apart into positive and negative ions. These ions carry electricity. The prevailing theory at the time by a guy named Arrhenius said that the more you dilute the water, the more the salt breaks apart and the better it conducts.
Seems logical enough.
It worked great for weak acids. But for strong electrolytes, like simple table salt, the mass completely fell apart. The theory predicted one thing, and the experiment showed another. It was a massive embarrassment for chemists.
And Ghosh figured out why.
He flipped the script. He proposed that strong electrolytes are completely ionized to begin with. They are already fully broken apart. The reason conductivity changes isn't because of the number of ions, but because of the crowd.
The crowd.
Imagine a crowded dance floor. The people are the ions. They're all free to move, but because there are so many of them and they are charged, they get in each other's way. They attract and repel each other.
So the electrical force between the ions is slowing them down.
Exactly. It is an electrostatic force field. Ghosh developed the mathematical model, Ghosh's law, that accounted for these interionic forces. It involves the cube root of the concentration.
And this wasn't just a minor tweak. This was a stop the presses moment.
It was. Giants like Max Planck and William Bragg applauded it. But what makes Ghosh Giridih's story isn't just the theory, it is what he did with it. He was a nation builder. He looked at the coal mines of his hometown and saw the future.
The sources mention the Fischer-Tropsch synthesis. That is turning coal into liquid fuel, right?
Yes. India has a lot of coal, much of it right there in Giridih, but not much oil. Ghosh realized that for a newly independent India, energy security was everything. He pioneered research into converting that solid coal into liquid petroleum.
So he is taking the raw geology he saw as a kid and applying world-class chemistry to power the nation.
Precisely. He goes on to become the first director of IIT Kharagpur, the director of the Indian Institute of Science in Bangalore, and a member of the Planning Commission. He is the bridge between the raw resources of the plateau and the industrial ambitions of the state.
Which is a perfect segue to our third titan, because if Ghosh was about using resources, this next man was about measuring them. Prasanta Chandra Mohalanobis.
The professor, the man who basically built the dashboard for the Indian economy.
Now, Mohalanobis is usually associated with the Indian Statistical Institute in Calcutta, but he had a place in Giridih, too.
Rose Villa. And again, The sources are very specific. This wasn't a vacation home, it was a functioning laboratory. In fact, some of the most practical statistics work of the 20th century happened in the gardens and fields around Rose Villa.
We are talking about the crop cutting experiments. Now, crop cutting sounds a bit agricultural for a master statistician. Why was this so important?
You have to understand the problem. In the 1930s and 40s, how did the government know how much rice or wheat the country was producing?
I assume they just asked the local officials.
They did. And the local officials usually just guessed. Or they looked at the field and said, "It's like a good year." The data was garbage. And if you don't know how much food you have, you can't prevent famine.
So Mohalanobis wanted scientific precision, but you can't harvest the whole country just to weigh it.
Right. You have to sample. But sampling is tricky. If you tell a field worker to pick a random spot to harvest, they will almost always subconsciously pick a spot where the crop looks healthy.
Human nature. We avoided the bare patches.
Exactly. That introduces massive bias. So Mohalanobis used Giridih as his testing ground to solve this. He experimented with different shapes and sizes of sample plots to find the most accurate method.
And he landed on the 4-foot circular cut. Why a circle and why 4 feet?
This is the genius of the mechanics again. Think about a square plot. You have to mark 4 corners with pegs, run string, and then you have a long perimeter. The worker has to decide for every stalk of wheat on the line, is this in or is this out?
Oh, the edge effect.
Huge source of error. A circle has the smallest perimeter for a given area. Less edge means less error. And mechanically, you just give the worker a pivot stick and a 4-foot rope. They stick the pivot in the ground, swing the rope, and cut everything inside the circle. It is idiot-proof.
That is brilliantly simple.
It is. And that 4-foot circle became the gold standard for the National Sample Survey. It allowed the government to accurately estimate food production for the first time.
So he is treating the fields of Giridih like a giant chalkboard for statistics.
He established the Agricultural and Ecological Research Unit right there. He was looking at flood control on the Mohanadi River. He was looking at crop yields. He was using Giridih to test the Mohalanobis model that would eventually drive India's second 5-year plan.
And we can't skip the Mohalanobis distance. That is his famous contribution to pure stats, right?
The d-squared statistic. Yes. It is a way of comparing populations across multiple variables. Interestingly, it started with anthropometry, measuring physical features like the skull measurements of Anglo-Indians, but the math was refined during his time in Giridih. It is now used in everything from pattern recognition to machine learning.
It is incredible. You have Bose listening to the boundary of life, Ghosh unlocking the energy of coal, Mohalanobis measuring the harvest, all in this one small town.
And this brings us to the network part of the story. Because these men didn't just happen to be there. They were friends. They were classmates.
The sources call it the Presidency College Galaxy.
It is a fitting name. You had J.C. Ghosh, Meghnad Saha, and Satyendranath Bose, the other Bose, famous for Bose-Einstein statistics, all studying together.
And they all converged on Giridih.
Frequently. Satyendranath Bose was the president of the ISI, so he was often at Rose Villa with Mohalanobis. Meghnad Saha, who gave us the ionization equation for stars, was the architect of the Damodar Valley Corporation. The Damodar River flows right through this region.
So Saha is applying astrophysics-level intellect to flood control in his friend's backyard.
Exactly. They visited each other, they debated, they collaborated. Rose Villa and Vijay Kendra became these informal university campuses where physics, biology, and statistics all bled into each other.
It is really a picture of interdisciplinary science before that was a buzzword.
Yes. Before we close, I want to touch on one more layer. We have talked about the people and the climate, but we need to talk about the ground itself again, the geology.
Right. The sources mention the Karharbari Formation.
Yes. The ground they were walking on is scientifically significant on a global scale.
Yeah.
The Karharbari Formation is a layer of rock from the Permian age, hundreds of millions of years old. It is distinct because it contains unique fossil flora, specifically a plant called Gangomopteris.
So before it was a hub for studying plants, it was a graveyard for ancient plants.
It adds a layer of deep time to the narrative. The coal that Ghosh wanted to liquefy, the coal that powered the trains bringing Bose to his retreat, that coal came from these specific ancient forests. It is like the land itself was waiting to be studied.
There's one final connection here that I absolutely love. It is a pop culture one. Satyajit Ray.
The filmmaker.
I knew he was a giant of cinema, but I didn't know about his connection to Giridih.
Ray spent time there as a child. His grandfather was a friend of these scientists. And if you read his famous science fiction stories, the Chronicles of Professor Shonku.
The eccentric inventor character.
Right. Where does Professor Shonku live?
In Giridih. beside the Usuri River.
Exactly. Professor Shanku is clearly a spiritual successor to J.C. Bose. He's a lone genius sitting in a quiet house in a hill station, inventing the anahilin pistol or the mercurial drug.
So Ray took the real atmosphere of the town, this buzz of high-level science in a sleepy setting, and turned it into modern mythology.
He cemented Giridih in the cultural imagination as a place where science happens. And that legacy isn't just fiction. The ISI still maintains a branch there. There are NGOs like the Banwasi Vikas Ashram applying scientific agriculture today. The ripple effect is still there.
So bringing this deep dive to a close, we started by asking why Giridih?
I think we can say it was a crucible. It offered a rare combination. It had the resources, the geology and industry to ground the science in reality. It had the environment, the peace and health benefits to allow for deep thought.
And it had the community.
That is the most important part. Rose Villa and Vigyan Kenro weren't stiff, siloed university departments. They were homes. These men could cross boundaries from physics to biology to statistics without anyone telling them that's not your department.
It forces you to think about how we design our innovation hubs today, doesn't it?
It really does.
We spend billions building massive, shiny tech campuses, cramming thousands of people into open-plan offices in the most expensive cities on Earth. We optimize for collisions and velocity.
But J.C. Bose unlocked the secret life of plants in a quiet house in the hills. Mohalanobis revolutionized economics in a garden with a 4-foot stick.
It raises a provocative question for you to mull over. Do our modern, hyper-connected, high-pressure environments actually suffocate that kind of deep, slow, interdisciplinary thinking? If J.C. Bose had stayed in the noise of Calcutta, would he have ever heard the plants seek?
Sometimes, to make the biggest noise in science, you have to go somewhere very, very quiet.
Ideally, somewhere with a nice river view and some interesting rocks.
And maybe a mercury coherer, just in case.
Exactly. That is it for this deep dive into the Giridih Connection. Thanks for listening, and we will catch you on the next one.